So following both Fernando and Peter is a little scary, but here it goes. So I'm Thomas Caswell. I'm one of the lead developers of Matplotlib, and I'm here to tell you about 2.0 and our attempts to change the defaults. So I work at Brookhaven National Lab. I'm local to New York, and this is my contact information on the internets. So just a bit of housekeeping. In September, we did a 1.5.3, which is hopefully the final bug release in the 1.0 series. We did that in September. 2.0 is coming. It's at this point over a year late from what we initially projected. We tagged the first beta in July in time for SciPy. There's a beta 4 which was out in September, and I tried to get a beta 5 out last night and found some more rabbit holes, so that'll probably happen this week or next. And you can install these right now, either through pip using pre, or they're up on Conda-Forge. So for all three major platforms, we have binaries, so you should be able to get all of this stuff I'm going to show you and play with it today. After 2.0, we're going to try to very quickly do a 2.1, which has which will hopefully be a new feature release. One of the goals is traitlets, so we're going to trailetify the entire library, which should make interacting with IPython, the Jupyter universe, much easier, and also provide a serialization path. And one cool thing that's currently on master is you can pass a list of strings, and it will identify those as categoricals and more or less do the right thing to plot them. And then a little longer term, in SciPy 2018, we're going to do whatever 2 point we're at then is going to be the last one to support Python 2. And going forward, we're going to go Python 3 only. We'll do bug fixes for that last release until Python itself drops support for 2. And if you want more information, the first link here, which is Python 3 for Scientists, is the carrot of why you should switch to Python 3. And the second one is the stick of why you should switch to Python 3, depending on which you would rather be persuaded by. So, Matplotlib is, as I'm sure you're aware, an old library. I think go back 15 years or so. And at the time, a lot of our styles were taken from MATLAB, whatever it was doing at the time. And they've, to put it nicely, they appear dated. So to address this, we decided we'd just change the defaults. We said, great, we've got this RC param system. We can configure defaults in a file. We'll just change those. Maybe one or two things we have to track down. Maybe a month, maybe 2, and we'll get out the door and be done. And it has been a year of dragon-infested rabbit holes as you change something and you realize that there's some assumption that was making that breaks something else, or just, So, and so now I'm going to start into the live demo immediately. So one thing I'm going to be showing off is the notebook backend, which, so in the notebook I have a live figure, I have panning, oops. I have zoom, come on, if I can use my mouse. Here you zoom, if you hit the, oh, that, great. We capture all the key events and any of the events that you'd expect in the GUI. Any of the user interaction events you get from the GUI, you can get in the web browser. And this talks back to the running process where we run your image and ship the ping back to the browser. So everything you expect from a traditional GUI, you get here. So one thing we're relying on very heavily going forward is in 1.4, we added a style module, which is a way to basically load partial RC params. So for instance, if you like the seaborn colors, oops, you see the plot re-renders and the seaborn color sheet. Turns out you hate everything I'm about to show you. We have a classic style sheet, which we'll get you back the 1.x behavior, and we're currently running pixel identical tests as part of the continuous integration that in classic mode you get back exactly the plot you got before. But this is a global thing, so I'm going to go back to it so that they don't need it on the next page. And this is the current list of style sheets we ship with. So if you like the Seaborn styles and that's all you're using from Seaborn, you can now just use it directly. However, if you do statistical stuff, Seaborn is great for that as well. So this is the list of things we have. You can register your own, and we're very liberal at merging these. If you have a style sheet you like, great. So one of the most obvious things is we've changed the default color cycle for lines. The classic on the left, the new ones on the right. These are taken. This is the category 10 from Vega Lite D3 and Tableau. That's the lineage of that. And notice that these colors are defined by hexes. And on this side, we have these C and then an integer. For 2.0, we've added a new way to specify a color, which is the letter C, capital C, and then an integer, which goes out and gets the color from your current color cycle. So you can see here, I've specified the color of these lines to be C2, C3. If I change to Seaborn, you can see the colors change. If I change this to, they change back to again what they are in the classic style. So there's now a way to write, specify specific colors, but then have it track your overall style, which is kind of nifty. All right. And again, another thing that is already on your computer, if you've been keeping up to date, is in 1.5, we picked up a new dependency on a project called Cycler. The docs are there. And this is a very thin wrapper around basically itertools.product and itertools. And zip. And it lets you specify basically something that has a name and then a sequence, and lets you compose them in ways that make sense. So if you do plus, you get the zip. If you do times, you get the outer product. And in these things chain the way you'd expect. And that when you come back to something short so we can fit this on the screen. And what's in here is just, if you iterate over them, you just get out the dictionary for that row. So now if you've got things that take in quargs that you want to broadcast across, you can just loop over this, star quargs, and you're off to the races, which is what this is a demo of. So we just changed this to C3. That was a little more than I wanted, but just to give you an idea of what's going on under the hood with this. And again, this is something that you probably have on your computer right now that you can just use. And one of the changes we made is that there's a new RC param in 1.5, which is prop cycle. So now instead of cycling just the color by default, you can assign a cycler to this, and you can cycle line style, marker style, line width, color shape, all of this by default. Let's just show you this works. If I change this to plus, whoops, you see that the order of the cycling changed. So one thing in 2 by popular demand is many more things now follow the color cycle by default. For example, scatter, as I'm sure many of you have hit, it would always come up blue. And you do 4 scatters and you couldn't tell them apart. They now color cycle by default. Another thing is the legend has been changed. It now tries to find the best location by default, so as you pan around, the legend gets out of the way. And this one. This is one that sounds easy. We should, if you look at this in classic mode, oops, as the lines get thicker, the dots, what was a set of dots, starts turning into a series of vertical bars, which just looks, horrendous. So great, we can do some math. We can scale the dash size. We can scale the dash size, the dash pattern with the line width, and everything sounds great. But then now you've got a whole bunch of things to keep track of, and this turned into a 20-hour archaeology activity. But it works now. So, all right. And so something else that's in 1.5 that we'd like to encourage people to use more, this is actually something that is at Fernando's great urging, is almost all of the plotting functions now take a data quarg. And the thing that goes in there is anything that supports getItem with a string, and it returns to you something that looks like a NumPy array. So in this example, we've got a data frame which just has angles and some trig in it. And if you just do plot th data and then data equals df, and we extract the label correctly, and the plot shows up as you'd expect. Also in 1.5, which again, already on your computer, we've got better support for, thank you. We have better support for pandas natively. I'm just going to go, come on. If you just pass us a series, we'll identify that it has a label and use that to label the legend. And if it has an index, we'll use that as the x-axis instead of range. So again, these are things that you can use right now that hopefully will make your life better. Okay, so one of the most visible changes is we've changed the default color map away from jet. And as part of this, Nathaniel Smith and Stefan van der Walt developed some software to evaluate color maps and to look at them and develop them. And you'll hear about, I think you'll hear much more about this after lunch. To work, great. So this is the package is VizCM, which again they developed it as a little GUI thing, but because they only used Matplotlib's GUI interaction widgets, it runs, in the browser. You can look at the gamut. You can look at the various things here. If we go up to this, oh, why did you do that? And just for comparison, if we look at jet. If you believe the claim color map should be perceptually linear, just don't. All right, come on. So one of the other changes is that for reasons unknown to me, the default interpolation when you did IM show was bilinear. So even if you have only 5 by 5 pixels, you get something that looks like this, where we try very hard to smooth it. The default is now nearest, as you probably want to see when you look at an image, particularly if you're looking at heat maps. But this led us to a very interesting, very old bug. So this is using Veritas, which if you recall, there is no red in Veritas. But if you look at all these interpolations, you're seeing these bits of red, which is a little scary because there should be no red in this plot at all. And what was going on was that this comes back to what Peter's saying about data shader, is that you have to be very careful how you, and actually a question from the first talk, how you have to be very careful about artifacts you introduce. So what we were doing is we were taking your input data, we'd normalize it to 0 to 1, via your log norm, your linear norm, whatever you want to use. We then map that to RGB space using the color map of your choice. And then we would take that and resample to fit it to the number of pixels on your screen. Which if you're using something like jet, this probably was there and you just didn't notice because jet is awful. But once you start having perceptually uniform color maps that are not linear in RGBA space, when you do this interpolation, you start getting colors that aren't in the color map when you've got wide variations between pixels and you cut the corner. So as part of this, we completely rewrote how images get handled underneath. Now we normalize them, resample them, and then map them to RGBA, so the colors you get at the end are the correct colors. I'm going way too fast. That's okay. So one of the persistent complaints we get, or complaints isn't, a persistent support request we get is how to get non-ASCII text into plots. For instance, if you or anyone you know works in Cyrillic, this can be painful. Our default font for 2.0 is a much larger font. It contains almost all of the Western alphabets, including emoji. So everything on this plot there's no math text here, there's no funning here. This is just the default behavior. You can type Unicode at it, and it mostly handles it, including the biohazard symbol. I don't know why that's just fun. Another amusing thing that happened is XKCD ran a survey where they asked people to name RGB colors displayed on their monitor, and then they did a massive machine learning problem to identify names to hex values. And we now ship with that mapping. So any of those colors, if you put the string XKCD : and then the name, you'll get the XKCD colors. If you want access to almost 1,000 named colors. And then I guess I've talked way faster than I thought I would. So if you go to matplotlib.org/devdocs, this is a version of the docs that we build every time we merge to master. And you can see a draft of the default style changes. Let's see if this is going to, oh, no internet connection. Oh, bad. Oh, no, good. Well, I can't show it to you because I don't have the internet. So there's a bunch of other nice things. So if you have 153, one thing you have right now is when you import pyplot, it will detect if you're running inside of IPython, and if so, just connect to the event loop instead of having to type magic matplotlib qt or whatever you want. Something that will be coming with 2.0 is the notebook backend I've been showing you actually predates the current widget framework. We kind of just make our own comms and just kind of sideband the whole thing. Sylvan has been, Corley has a version of that backend that integrates correctly with the widget framework called IPyMPL. It's a standalone project, so it can spin not at the glacial pace of upstream. And it requires some things for 2.0, so as soon as we get 2.0 released, you will get that. A bunch of high DPI stuff that is now correctly handled. People who use the native Mac backend, historically that has used its own, it used Mac's image rendering to do all of the rendering from Python's Matplotlib's internal representation of the artists to the screen. In 2.0, we've switched to it to being ag-based like the rest of the GUI backends. So now what you see in your native OS X window will match what you get when you save the ping. We fully support Qt5 as near as we can tell. So if that's the thing you're doing, you're good. As of 1.5, if you ever use the object-oriented API, so instead of you do line gets ax.plot, and then you do line.setColor to change the color. Previously, you'd have to then manually call a draw to update the figure. As of 1.5, that happens automatically. And since I have time, I'll show you a demo of that in a minute. And one other nice thing is, oh, thank you. We would get requests to do automatic binning in plt.hist. And we said, that doesn't sound like a plotting problem, that sounds like a NumPy problem. So they went to NumPy and said, can we have automatic binning selection? And as of NumPy 1.11, that is there. So if you pass bins equals string auto and have NumPy 1.11, it will pass through and do the right thing. Right. So just a little bit more bookkeeping. So Matplotlib, we are still alive and well. We're not necessarily the shiniest and newest of plotting libraries, but we're still here. We've signed an FSA with NumFocus, so if you or anyone you know would like to donate money to us, we can take it. And we're in the process of formalizing our government, which is very closely copied from the Jupyter governance. We have an extremely broad contributor base, so this is basically a year and 9 months, year and 10 months worth of commits. Cumulative commits by author. So you can see we've got some contributors who do a lot, but we have an extremely long tail of people who come by and provide us, a documentation fix, a bug fix that they hit, small things like that. So I think we're very healthy in that regard. And just, on the metric on that, if you look at our commits and committers per week, we're pretty active. I think it's just a comment on where, as a project, we see ourselves in the going forward. So one thing is that as a project, we are quite friendly. We've gotten some feedback that we seem standoffish and such. It's not that we're just very, very slow. So if you talk to us and don't get a response, just try again, please. We'd love to talk to you, just bandwidth. And we're always looking for new contributors. If you're qualified to use Matplotlib, you're qualified to work on a vast majority of the library. And one of both the great things and, from my point of view, kind of scary things about Matplotlib is that the uses of it is now way outside the core domains of the core developers. And in order to provide the good user experience you really need domain experts to tell you what the common plotting patterns are, what things need to be easy. You don't necessarily always want to trust physicists to write your plotting code. So we're always looking for domain experts to help build out domain-specific plotting libraries, which there's a talk later titled with almost that title. And so we're interested in trying to develop a scikit-style community of MPL-statistics, MPL-finance, MPL-whatever your domain is. And if you're interested in that, please come talk to us. And really, we just want to be that substrate that sits at the bottom, and other people can build exactly what they need for their users on top of us. Right, so that, I guess I'm up here talking, but as Fernando correctly said, these are very large projects. See our founder, John Hunter. And this is the very small list of the 200-something people who've contributed to Matplotlib in the last year and a half. So with that, I have 5 minutes. So I guess I'll take questions, and then if I don't have questions, I'll do demos, or live demos. Is there?
So I know there's some 3D plotting capability in Matplotlib, but that it has some fundamental disadvantages. I'm wondering if there's any intention to continue developing that, or if you think of other plotting libraries or platforms.
So the question is about the mplot 3D package and the 3D plotting we support, and what the trajectory of that is. So the 3D support we have is it's a clever hack. We do the computation on the back, we do the projection on the back end, then we regenerate the artist, and then just render those using the normal pipeline. Which, if you only have one surface, this actually works out extremely well. Where it gets difficult is if you've got two surfaces, we don't have a Z buffer, so you get these Escher effects. And really, the way to fix that is you need to go to something like OpenGL for that, or write your own Z buffer. If someone's interested in that, we'd love to talk to you. But I guess that kind of dodges the question, but Nathan? So the question is about plans past 2.0, or past 2.1 and long term. I'm not sure I want to answer that question on a microphone. Well, in the sense that I have thoughts, but I have not written them down. I'm not discussing them with anybody else, so I don't want to, run over any process here. But sorry again for the non-answer. One thing, tying back to Peter's talk, there is a demo of tying data shader into Matplotlib, because it just generates raster data that needs to be triggered when you change your access limits. If anyone's interested in working on that, we would definitely love to talk to you. But any other questions? No? OK, so then I'm going to see if I can do a really live demo. OK, so just to show you, I have nothing on my sleeves. I'm going to quit. The ion turns interactive mode on, so as soon as you create a figure, it'll be shown. I can do ion, comma, gets. So now if I decide that's on this big screen, that's a little thin. we can change. So just, I don't know, I've got 3 minutes left. Does anyone have any particular thing, maybe? No? Okay. Oh, Peter? No, unfortunately. Yeah, but I have no faith it'll work in 3 minutes.
There's a really cool, here, I'll show you. Is there like a webcam?
Again, not that I have faith I can get to work in 3 minutes. No. All right. I guess no one's ever happy if you go to lunch early. I'll be around all day if you have questions.